Hey everyone, we're going to start chapter 11, which is the first section of Calculus 3. The first section is on the different types of coordinate systems we're going to use in 3-space or 3 dimensions. Now, as you're familiar with, we have our 2 dimensions. X goes in the horizontal, Y is in the vertical. And different books use different things, but our book uses the following setup. Z is now the vertical axis, that's up and down. Y has shifted to left and right, and X is in and out of the plane. X positive is towards us, X negative is into the paper. This is a little bit different than like if you use something like Unity software and other things where Y is up, X is right and left, and Z is in and out. In this book, we're using this. We shifted from having 4 quadrants to now we have 8 octants. So there's basically we're doubling up this one, a positive half for the positive Z and a negative half for the negative Z. So 4 and 4 is 8. It's a lot of the stuff you're familiar with remains the same. The distance formula in 2 dimensions or 2 space is x minus x naught squared plus y minus y naught squared. We take the square root of that value. And 3 dimensions, all we do is add in the z component, z minus z naught squared. If you want to see how that works, we'll take a look at the setup for it. We look at a picture in 3-dimensional space. Let's picture the origin in this graph as x, y, z. And if we come out to x naught, go right to y naught, and up to z naught, we're right here. Now you got to kind of like picture this because I'm writing a 2-dimensional figure in or a 3-dimensional figure on a 2-dimensional space. But the first thing we can do is we look at this triangle right here, where this is going from x to x naught and this is going from y to y naught. D2 is that formula I just gave. X minus x naught squared plus y minus y naught squared. We take the square root of it. And then the distance to the upper corner going from across the diagonal of this cube is now using this triangle, D2, and then z minus z naught is this length right here. So we have D2 squared plus z minus z naught squared. But we have D2. D2 was this value up here. So we're just plugging that in and we're left with our 3-dimensional distance formula. And that'll be it for the first segment. I'm breaking this up into pieces to make this more watchable. Peace.